Okay, so now let's talk about prime numbers, right? And so prime numbers are, by definition, they're any number that can be divided by one outside of one in itself, outside of one in itself. If you can't divide it by another number, then it's prime. I'm going to create extension on an array of integers or on integer. Let's start with on integer. Let's try to do an extension on integer. Because that's what we have. Extension, int, right? And we're gonna say we're gonna write a function that tells us if something's prime. Func is prime. And right now we're just returning a boolean. I hate when I do that. Oh my god. Return. And so is 12 is prime. Is 12 is prime. I put false, of course. True is, I mean, it is not prime. It's false, right? Not a prime number. Okay. Give me a second, people. All right. And I gotta give me a drink of water. Okay, so let's do this. Let's do this. Um. Okay, so I'm getting self. I'm setting a variable set to self, which is whatever the number is, and then n is for number, as a lot of you guys know. So because it's less than or equal to 1, it cannot be prime. Okay, and if it's less than or equal to 3, outside of 1, yeah, it's prime, right? And right, and so while I'm going to set I equal to 2, while I times I is less than or equal to the number myself, right? Well, I times I is less than 12 in this case, right? If n modulus I, that means if n is evenly divided into, if I is easily divided into n, that's what we're asking. This is asking if I is equally divided, evenly divided into n, then we're gonna do this. Where is my there we go. I'm looking for my cursor. So I equals I plus 1. Or plus equals 1, whichever you want to do. Okay, so all this stuff has opportunity to fire off. This prime, no, it's not prime, it's false. And we're right here. Okay. We know that we can fire while in is evenly divisible by I. Return false. Okay, now you can go back and do your research and see how this works. That's your homework. Okay. 11. Well, even 111 is prime. Oh, it is not prime. I'm sorry. You know why? 11 times, I don't know what. But I know what's prime. 83 is prime. I can think off the top of my head. 83 is prime. Yep, told you. All right. So now that we have that, create a function, right? Let's return an array of prime numbers. Okay. So we're going to say there's a lot of ways I can do this. I'm thinking it just hit me a way that I could do this. Okay. Um fetch fetch numbers. Fetch prime numbers. Prime numbers. Right? Fetch prime numbers. This is an array of integer. Okay. And we can do it like this, var. Oh no, 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 no. You're killing me, bro. You're killing me. For I in 2 dot self. And actually it should be dot dot, right? Or dot dot less than self. And then if I dot is prime, because that's an integer. See that? I'm using this function right here. That is prime output dot append I, right? And then we can say return output. Yeah. So now let's see. 12 dot fetch prime numbers. 2, 3, 5, 7, 11. We have that. And there are other ways to do this. There are other ways to go about doing this. This is the way I chose to do this today. And what I'm going to do, I can't wait to show you some of my control structures tutorials because it'll help you understand while loops better, for loops, in a way that you can do this without even having to write a separate function, even though that's not all bad. Okay, on to the next.